Okay. Oh, here we go. Oh, it's just 3 and 4. Probably the easiest question in this paper. I don't know. Or at least from vectors. In a game, a ball B is rolled across a horizontal surface towards a fixed target. Alright. The ball is modeled as a particle moving at constant velocity. At time t is equal to 1, the position vector of B is this. Okay, I got it. At t is equal to 1 and at t is equal to 9, that's there. What is the velocity of the ball? We just have to find out the velocity. Let's do that actually. Velocity is just a random equation. Let's just say v is equal to u plus at. Now, here, the thing is, we don't... Okay, wait, is this constant velocity? Oh, this is constant velocity. Always read the questions, folks. So constant velocity means that you can just simply use s is equal to vt, and v is just 1 over t times s. So 1 over t is just the time taken to move from the first position vector to the final position vector. The total time is going to be 9 minus 1, 8. That's the difference. You're moving for 8 seconds, right? You're starting at t is equal to 1 and then ending at t is equal to 9. So that's 8 seconds, okay? Don't take 9 or don't take 1. That's worse. So you have 1 over 8 times... okay, what is the distance traveled? Okay, we can just stay in the vector form for now. Okay, we actually have to stay with vectors, right? Because they're asking us to find the velocity, and well, you can't just calculate the magnitude and say that that's the velocity. Okay, so what about the displacement vector? What do we do about that? We can see that the initial position vector is this and the final position vector is this. So what is the movement? The movement is just going to... Okay, let's just say, just so that you can visualize better, let's say this is the whole graph right here, and the initial position is minus 2 plus 5, so that's like maybe somewhere here, and then the final position is 10i minus 3j. 10 minus 3j, so it's like there. Okay, this is my initial and this is my final. This is minus 2, this is 5, and this is 10, and this is minus 3. This looks very awkward, but yeah. So we're essentially moving from here to here. Okay? That is what we're doing. And we're really concerned about this displacement right here, this displacement vector. How do we actually find this vector out? Well, let's just show you how we can do that. This is the origin, and this is minus 2i plus 5j. So like, let's say this is A, and let's say this is C. We can't call that B, well, because this is just a ball B. That would just be confusing. So let's call this point C and call this point A. So OA is the vector minus 2i plus 5j, okay? This is OA. This. And this is our final position vector, OC, which is 10i minus 3j. Okay, this is OC. Now what we're worried about is AC. This is what we need. How do we find out AC? In other words, how do we go from A to C? Not just, straight from A to C, but using a different path. And that path is just this. A to O and then O to C. That's just I hope that's intuitive. It should be. So you have AO plus OC. AO, notice, OA was minus 2i plus 5j, so AO is like in the opposite direction, so it's going to be the opposite of this, so you're going to take minus. Okay, you're just going to multiply minus with this, so you'll be getting 2i minus 5j, and then plus OC. OC is 10i minus 3j. 10i minus 3j. There we go. Now you have 12i, and then you have minus 8j. This is really what we're concerned about. This is the displacement. This is what we're going to use here. 12i minus 8j. And there's another way you could simply do this. Instead of like visualizing like that, it's simply find out the change in displacement. The change in displacement is just the final minus the initial. Finally, you're at 10i minus 3j, and initially you're at minus 2i plus 5j. You just subtract that, you just find out the difference, and you get 12i minus 8j as well. I just wanted to show you the other method, sort of. It's the same thing, but yeah. Okay, now we're just gonna get 12 divided by 8. I guess that's 3 by 2i. Okay, there we go. 3 by 2i minus j. That is our velocity, and we're done. Okay, the position vector of the target is 39 minus 5j. I'm still at 82. Okay, 39 minus 5j. Position vector of the target is 39 minus 5j. Use the model to find the distance of b from the target at time t is equal to 7. Okay, the target is at 39 minus 5j. So we know where the ball is supposed to go. Okay, actually, since we just drew this graph already, what we can do is mark that target. The target is probably just going to be like here. I know it doesn't look scaled at all. This just looks like this is 20. Yeah, that's just 13. Just helps visualize it better. And this is, let's say, minus 5. This is really where we're trying to go to. This is the target. The point 39 minus 5j, the vector right here, that is our target. Use a model to find the distance of b from the target at time t is equal to 7 seconds. Oh god. How do we freaking do that? Okay, I think. Okay, first of all, we just need to figure out where the ball is at t is equal to 7. Why don't we do that? So like at t is equal to 7, you're basically moving for like, yeah, you're moving for 7 seconds, but we're starting from t is equal to 1, I guess. That's just the information we've been given. Like maybe at t is equal to 0, you're like here, and then from 0 to 1 you travel to a, and that's just the information they've given us. That's what's happening. So at t is equal to 1, you have this position vector. Oh my god, what is this? There we go. You have this. Okay, and at t is equal to 7, you will have been moving for, of course, 7 seconds, but now we're concerned about the change in time. That's just 6 seconds. So you're moving for 6 seconds. Okay, actually, let's just say at t is equal to 7. At t is equal to 7, we're gonna do s is equal to vt again. We're trying to find out s, right? Yeah, we're trying to find out s. We know the velocity. The velocity is we just found out that's 3 by 2 minus j, and multiplied by the time. What's the time gonna be? Well, we're traveling for. We're really just concerned about where we end up after 6 seconds from t is equal to 1. So 6 plus 1, that gives us 7. That's just going to be t is equal to 7. So we're going to have to use 6 here instead of 7. All right. Now, or actually, no. I think, yes, we actually have to use t is equal to 7 here because, well, we're not really concerned about that, right? The thing we just did, because this is, like, think about it, this is just a normal velocity. This is what we're moving at. And you're starting from t is equal to 0, you're going to 1, 2, 3, 4, all the way to 7. And really, this is what we're concerned about, so we could just use 7 seconds of travel right here. Yeah, I'm extremely sorry for what I said there. My bad. This is what you have to do, okay? 7 times 3, that's 21 by 2. I minus 7j meters. There we go, that's s. That's where we're at right now. That's where we're at. And we're concerned about the distance. Wait a second, this just doesn't look right. No, actually, I think it's fine. It probably is fine. It just feels a bit weird because you have minus 7j over here, and minus 7j is just like below minus 5j, right? So how would you, like, if you're traveling from like here and then going in this direction, how do you even, like, dude, how do you even like go to minus 7 at all? All of this just really doesn't make sense. Okay, I see what's going on. I have made another mistake. This is what the equation is supposed to be. The change in displacement is equal to vt. We can't just say s is equal to vt. Okay? We are starting from an initial position, and that initial position is minus 2i plus 5j. Okay? So, like, the final position, let's call that position vector sf. Okay? F for final. minus the initial position vector. Initial position vector is minus 2i plus 5j. That is really what we just know. Otherwise, if we had known t is at what position vector b is at t is equal to 0, we would have used that. But now we have to use this. Okay, and this would be equal to 3 by 2i minus j times, this time is going to be 6. So I was going down the right track, but I just forgot about the displacement thing here. So I guess in a way that was, I hope that was beneficial for you guys. You just saw how I almost made a mistake, and then you saw that I realized I was just fumbling. So yeah, that's really what you're supposed to do. And then SF just becomes, well, the final position vector is minus 2i plus 5j plus 6 by 2, that's 39i minus 6j, okay? And this is just 7i minus j meters. Okay, this is where we're at. Now that makes sense. Okay, 7i. So, okay, now you just realize that how helpful, how beneficial it is for you to just draw a simple, rough sketch of the whole scene here. You know how I figured out, like, there was something wrong? You know how I got minus 7j, and I saw that the final target is like minus 5, and we're moving towards this direction right here. How are we at minus 7 already if we're moving in this direction right here? How do we even get to this point? That's what my thought process was. Okay, very annoying. I don't know how long this video has been recording for. We're just at question 5. It shouldn't have taken this long. When did I start? Oh my god, 11:49, I think. Oh shit. Okay, doesn't matter. 7i minus j, there we go. And I just want to find out the distance of b from the target at time t is equal to 7. So at t is equal to 7, I see that we're at 7i minus j, and the target is at 39 minus 5j. We just have to find the distance between the two position vectors. And we've already seen how we can do that. We just saw how we found out AC right here, and we're just going to do the same thing again. Let's just show what I'm going to do here again. Let's just erase all that. This is the target, okay? And we're at, like, over here. No, wait, where we are? We're at 7 minus j, right? So, like, here and then here, okay? Let's say the ball B is here. So this is the position vector OB. What the fridge? Come on. Okay, there we go. And this is the position vector of the target. Okay. Now, we're concerned about this. We're concerned about what's going on between them. You know what I mean? We want the T's. Okay. B and T. So if we want to know what's going on between them, we need to find out the position vector relative to one another. That is what we need. We need to find out BT. BT is what we need. And then from that position vector between them, we can actually find out the distance by just taking the magnitude. So that's what we're going to do. How do we find out BT now? Well, from B to T, how do we go from B to T? We could just go to B to O and then O to T. Simple. I mean, of course, we could just go from B to T directly, but what we're trying to do is trying to find an alternate way to get to T. So that's what we're going to do. BT is going to be BO. BO is just the, okay, where's, okay, 7i minus j, right? So OB is 7i minus j. So BO is going to be minus 7i plus j. Okay? And then plus OT. OT is 39 minus 5j. There we go. And this is just 30 minus 7, which is 6i minus 4j. Is that right? Again, if I've made any mistakes so far, please feel free to comment down below. 13, okay, 1 minus 5, yeah, that's right. So we're concerned about 6i minus 4j. This is the position vector relative to one another. Specifically, this is the position vector of t relative to b, okay? That is what bt implies. You know how we say that the position vector of t relative to the origin is this? That is essentially OT. That is what OT means, okay? So that's what BT means with the same analogy. So 6i minus 4j, we just need to find out the distance. So we need this, the modulus, root over 6 squared plus minus 4 squared. And feel free to answer this question in the comments, like, do we really have to include this minus here all the time? Or like we know we're just squaring it, so that minus really doesn't matter. So do we really have to include that in there just to show that that's what we're doing? Or it just doesn't matter? Just, I don't know. And I guess it's a fun way to see if you're actually watching the video, then you're gonna watch me say that. And feel free to comment if you know anything about that. 6 squared plus 4 squared, that's going to be 213, and that is our answer. You can just keep it like that, or just 7.21 meters or kilometers? Meters. Yeah. How can it be kilometers in a game of football? Okay, whatever. Oh god.